Good morning, everyone. Today is the session 22 of NEET Physics, and the topic is rotational motion. And I have taken this question, which was asked in the NEET examination in NEET, I think 2017. In NEET 2017 और I think 16. तो ये क्वेश्चन जो है नीट एग्जामिनेशन में पूछा गया था. And the question is, two discs of the same moment of inertia rotating about an axis perpendicular to the plane of the disc with angular velocity omega 1 and omega 2. There are two discs of the same moment of inertia and rotating about an axis which is perpendicular to the plane of the disc with angular velocities omega 1 and omega 2. Now they are brought in contact face to face. They are brought into contact face to face with the coinciding axis of rotation. The question is, what is the loss of energy in the process? ठीक है, तो यहाँ पर there are two discs which has got the same moment of inertia. ठीक है ना, तो हम यहाँ पे लेते हैं कि let the moment of inertia, ठीक है ना, first thing is that let us assume that the moment of inertia of both these two discs B, आप इसको I ले सकते हैं. ठीक है, so I have considered that the moment of inertia of both these two discs is I. Now here the most important thing which we have to remember is that the angular momentum is constant when the net torque acting on any body is zero. ये फॉर्मूला आपको याद होगा और याद होना भी चाहिए. That is, the rate of change of angular momentum is given by this equation. That is, rate of change of angular momentum is equal to the net torque which is applied on the body. Now, if the net torque acting on the body is zero, then the rate of change of angular momentum is zero. ठीक है, then dl upon dt is equal to zero. यहाँ पे L क्या है? L is the angular momentum. So then the rate of change of angular momentum is equal to zero, or we can say it implies that the angular momentum, that is L, which is equal to I omega, is constant. So this is the concept which we have to use in this question. We have to use this concept in order to solve this problem. So since now I have taken the moment of inertia of both these discs as I. उनका जो angular momentum है एक का, the angular momentum of one of the discs is omega 1 and the angular momentum of the another disc is omega 2. So it implies that if the net torque acting on a body is zero, then the rate of change of angular momentum is equal to zero, or we can say that the angular momentum is constant. Now angular momentum is given by I omega, so I omega 1 is equal to I omega 2, or we can say that is the total, अगर हम बात करें angular momentum, that is the total angular momentum, total initial angular momentum of these two discs will be equal to I omega 1 plus I omega 2. ये मेरा initial, this is the initial angular momentum, and now when they are brought in contact face to face with the coinciding axis of rotation, then in that case, since the angular momentum is conserved or it is constant, therefore I omega 1 plus I omega 2 will be equal to what? So when they are brought in contact face to face, then what the moment of inertia क्या हो जाएगा? It will be I plus I हो जाएगा. ठीक है. So when they are brought in contact face to face, then let us say जो angular momentum है, sorry, this omega is the angular velocity, and so agar when these two bodies are brought in contact face to face with their coinciding axis of rotation, so let us say in that case the angular velocity becomes omega. ठीक है, where I am just writing is that where omega is the angular velocity of the two disks in contact with each other. In contact with each other. ठीक है, so this is the initial angular momentum, that is when they were not in contact with each other, and when they are brought in contact with each other, then we will get this equation. This is the initial angular momentum, and since angular momentum is conserved or it is constant, therefore the initial angular momentum will be equal to the final angular momentum. So if the angular this velocity of the two disks which are in contact with each other, ठीक है ना, with their coinciding axis of rotation, then I omega 1 plus I omega 2 will be equal to I plus I omega, where I is the moment of inertia of the two disks. Means that is, this is the moment of inertia of the individual disk. ठीक है, दोनों की जो moment of inertia वो बराबर है. So इसका मतलब क्या हो गया कि ओमेगा जो है, ओमेगा is what? This is the angular velocity of the two disks when they come in contact face to face. So omega will be equal to I omega 1 plus omega 2 divided by 2I. तो ये I और I कैंसिल हो जाता है. So the final angular velocity when the two disks come in contact with each other will be equal to omega 1 plus omega 2 divided by 2. ठीक है, ये आपका हो जाएगा, ये आपका आंसर आ गया. Now we have to find the loss of energy in the process. So first of all, in order to calculate the loss of energy, we have to find the initial first of all find the initial kinetic energy. Now the kinetic energy is given by the formula, that is kinetic energy क्या है? Kinetic energy, we have to find this first of all the initial kinetic energy, and then we have to find the final kinetic energy, and the difference of this initial kinetic energy and the final kinetic energy will be the loss of energy. And the kinetic energy का जो formula है वो होता है half I omega square. ठीक है, तो we will be using this formula now in order to calculate the initial and the final kinetic energy. ठीक है, ये initial and the final kinetic energy ये हम जो है हमको निकालना है. So we will be using this formula in order to calculate the initial and the final kinetic energy. So the initial kinetic energy कितना हो जाएगा? इसको मैं लिखता हूँ KE initial. This will be equal to half I omega 1 square plus half I omega 2 square. And what will be the kinetic energy? Final kinetic energy when these two disks are in contact with each other, that will be equal to half. The moment of inertia will be equal to the sum of the moment of inertia of both the disks, that is I plus I omega square. And what was the value of omega? Omega was omega 1 plus omega 2 का whole square. That is omega 1 plus omega 2 डिवाइडेड बाई 2 का होल स्क्वायर। ठीक है, सो द लॉस ऑफ एनर्जी कितना हो जाएगा? Loss of energy in the process will be equal to is my this minus this, that is equal to half I को मैं कॉमन ले लूंगा, half I omega, or we can simply say that it is not necessary to take common at this stage. We will write as half I omega 1 square plus half I omega 2 square प्लस ये हो जाएगा 2i हो जाएगा, दैट इज हाफ इंटू 2i विल बी इक्वल टू i, ये हो जाएगा ओमेगा 1 प्लस ओमेगा 2 होल स्क्वायर डिवाइडेड बाई 4, सॉरी माइनस हो जाएगा, दिस इज माइनस। अब यहां से हम क्या कर सकते हैं, वी कैन सिंपली टेक 1/2i जो है वो कॉमन ले लेंगे, ओमेगा 1 स्क्वायर प्लस ओमेगा 2 स्क्वायर माइनस, इसको अगर मैं ओपन कर लेता हूँ देन आई विल बी गेटिंग एज ओमेगा, ये हो जाएगा ओमेगा 1 स्क्वायर प्लस ओमेगा 2 स्क्वायर, ओमेगा 1 स्क्वायर ये हो जाएगा माइनस हो जाएगा बिकॉज आई विल बी ओपनिंग द ब्रैकेट, एंड माइनस प्लस ये दैट इज इक्वल टू माइनस 2 ओमेगा 1 ओमेगा 2। ठीक है, एंड बिकॉज आई हैव टेकन i by 2 इज कॉमन, तो ये आपका हो जाएगा, सॉरी ये हो जाएगा आपका दिस, एंड लेट मी राइट फर्स्ट ऑफ ऑल राइट इट लाइक दिस ओनली, राइट, अभी इसको दिस विल बी प्लस ओनली एंड दिस विल बी इक्वल टू i by 2 आई हैव टेकन कॉमन, तो यहाँ पर i by ये आपका 2 हो जाएगा। ठीक है, सो नाउ इसको सिंप्लीफाई करेंगे तो एलसीएम ले लेंगे तो इट विल बी 2, तो 2 ओमेगा 1 स्क्वायर प्लस 2 ओमेगा 2 स्क्वायर, ये हम ब्रैकेट को ओपन करेंगे तो ये ओमेगा 1 स्क्वायर माइनस हो जाएगा माइनस ओमेगा 2 स्क्वायर माइनस 2 ओमेगा 1 ओमेगा 2, सो दिस विल बी इक्वल टू, इट इंप्लाइज दैट द लॉस ऑफ एनर्जी कितना हो जाएगा, दिस विल बी इक्वल टू 1/2 i, ये हो जाएगा आपका ब्रैकेट में लेंगे तो 2 ओमेगा 1 स्क्वायर प्लस 2 ओमेगा 2 स्क्वायर माइनस ओमेगा 1 स्क्वायर माइनस ओमेगा 2 स्क्वायर माइनस 2 ओमेगा 1 ओमेगा 2, सो फाइनली आई विल बी गेटिंग एज ओमेगा 1 स्क्वायर प्लस ओमेगा 2 स्क्वायर माइनस 2 ओमेगा 1 ओमेगा 2 डिवाइडेड बाई 2। ठीक है, सो यहां पर इसको सॉल्व करेंगे हम and we will be getting the answer, that is it implies that the loss of energy will be equal to 1/4 I, इसको मैंने यहाँ पे ले लिया, I have multiplied 2/2 that is equal to 1/4 I हो जाएगा, ब्रैकेट में ओमेगा 1 प्लस ओमेगा 1 स्क्वायर प्लस ओमेगा 2 स्क्वायर माइनस 2 ओमेगा 1 ओमेगा 2 इज इक्वल टू ओमेगा 1 माइनस ओमेगा 2 का होल स्क्वायर। ठीक है, सो द लॉस ऑफ एनर्जी in this process will be equal to 1/4 I omega 1 minus omega 2 whole square, and so the correct answer is the option B। so यहाँ पर इस क्वेश्चन में जो सबसे इम्पोर्टेंट जो कॉन्सेप्ट है वो जो हमने यूज किया है, दैट इज द लॉ ऑफ कंजर्वेशन ऑफ एंगुलर मोमेंटम, एंड दिस होल्ड्स ट्रू व्हेन the net torque acting on the body is 0, that is we know that dl upon dt is equal to 0, is equal to the net torque which is applied on the body. So if the net torque on a body is 0, then this rate of change of angular momentum will be equal to 0. L यहाँ पर क्या है, L is the angular momentum which is equal to L is the angular momentum which is given by I into omega. So if the net torque acting on a body is 0, then the rate of change of angular momentum is 0, or we can say that the angular momentum is constant. Angular momentum is constant. So this is the concept which I have used in solving this problem. So I have calculated the initial angular momentum, and then I have calculated the final angular momentum, and then I have used the equation of this kinetic energy. That is kinetic energy हमारी हो जाती है that is equal to half I omega square. ठीक है. Now using this concept, that is the angular momentum is constant, I have found the value of the angular velocity when these two discs were brought in contact face to face with their coinciding axis of rotation. उस case में I have calculated the value of omega, which was equal to I think it was equal to omega 1 plus omega 2 divided by 2. So this was the angular velocity of the two discs when they were brought in contact face to face. तो मैंने इस कॉन्सेप्ट को यूज करके ओमेगा निकाला था, और इसको निकालने के बाद में देन आई कैलकुलेटेड द इनिशियल काइनेटिक एनर्जी, दैट इज द फाइनल. इसको निकालने के बाद में आई कैलकुलेटेड मींस आई वाज इन अ पोजीशन टू कैलकुलेट द फाइनल काइनेटिक एनर्जी. इनिशियल काइनेटिक एनर्जी तो आपका ये हो जाएगा हाफ आई ओमेगा 1 स्क्वायर था, और हाफ आई प्लस इनिशियल काइनेटिक एनर्जी वाज इक्वल टू हाफ आई ओमेगा 1 स्क्वायर प्लस हाफ आई ओमेगा 2 स्क्वायर, एंड द फाइनल काइनेटिक एनर्जी क्या हो जाएगा, बिकॉज काइनेटिक एनर्जी इज इक्वल टू हाफ आई ओमेगा स्क्वायर. सो ओमेगा की वैल्यू मैंने निकाल दिया था. ठीक है. एंड आई क्या हो जाएगा, इसका मोमेंट ऑफ इनर्शिया एक डिस्क का आई है, दूसरे का भी आई था, सो द मोमेंट ऑफ इनर्शिया वाज एडेड. तो हाफ सो फाइनल काइनेटिक एनर्जी क्या हो गया था मेरा, दैट वाज इक्वल टू हाफ 2i into omega square, where omega की वैल्यू थी omega 1 plus omega 2 divided by 2. So in this way we have solved this question, and we have calculated the loss of energy in the process, which is equal to 1 by 4 I omega 1 minus omega 2 का whole square. So the correct option is B. So in the next session, that is in the session number 20. So this is the first session from the chapter of rotational motion, and this is the session number 22. In the next session, that is in the session number 23, I will be coming up with some different types of questions which were asked in the NEET examination with respect to this chapter. So thank you very much for joining this session, and I hope you have understood the method of solving this problem. If you have any questions, definitely you can contact me on my mobile number, that is 9911 079547. This is my mobile number. You can contact me directly on WhatsApp also. So thank you again for joining this session, and have a nice day. Bye.